Hi, my name is Ahira Sanchez, and this is my presentation for biopsychology with Dr. Hansen. The topic of my presentation is the role of insulin in Alzheimer's disease. My objectives for today are to compare and contrast the mechanisms of normal functions of insulin and the mechanisms of insulin resistance, identify key characterizations of Alzheimer's disease related to insulin, and learn what interventions can possibly prevent or reduce the risk of Alzheimer's disease. So first I'll start off with the normal functions of insulin. Insulin is a secretion, hormonal secretion of the pancreas by the pancreatic beta cells. We know that insulin delivers glucose into the liver cells, fat cells, and muscle cells for cell metabolism. Essentially, insulin helps take glucose into cells for energy. We also have insulin receptors in the brain. Insulin, when it's secreted by pancreas, it actually travels to the blood-brain barrier, and in the brain, it has the role of creating new synapses and engaging in synaptic remodeling. We have found that there are high concentrations of insulin receptors. The olfactory bulb, the cerebral cortex, and the hippocampus are those three brain regions that have high concentrations of insulin receptors, which we know are areas that are very important for cognitive function and memory. And also, insulin is very important for modulating the neurotransmitters acetylcholine and the norepinephrine. Also, something that's very important about insulin is that it actually protects against beta amyloid plaques and phosphorylation of tau proteins, which we know are characterizations of Alzheimer's disease. Now, let's talk about what insulin resistance is. So insulin resistance is when the tissues in the body become unresponsive to insulin. And a key characterization of insulin resistance is that there is the phosphorylation of insulin receptor substrate 1. Take note that there is phosphorylation in insulin resistance, just like there is a type of phosphorylation of tau proteins in Alzheimer's disease. So insulin resistance is also characterized by the reduced insulin receptors and insulin signal markers in the central nervous system, partly due to that phosphorylation that I just mentioned. And because of that reduction, we find that because of insulin resistance not providing enough insulin and insulin not being able to provide that protection against beta amyloid accumulation, beta amyloid protein accumulation occurs and it disrupts the insulin signal and it just eventually destroys the hippocampal neurons. Also, this may eventually lead to cognitive impairment. And what they have found is that with intranasal insulin therapy, it actually can improve the cognitive impairment that can result from insulin resistance. Unfortunately, too much of it could actually make the symptoms of Alzheimer's disease worse and worsen cognitive decline over time. Other key characterizations of Alzheimer's disease include in that increased insulin resistance, there is a correlation with reduced cerebral glucose metabolism, also known as cerebral glucose hypometabolism. And they have found that typically this hypometabolism occurs in the default mode network brain regions, which are also regions that are very important for memory. And typically the hypometabolism is it's absorbed to start years before the onset of Alzheimer's disease. And what this leads to is a reduction in memory encoding. Also, another key characterization or other key characterizations of Alzheimer's disease is that there's an increased level of brain inflammation, which is associated with the vascular dysfunction and dyslipidemia. And so it has been found that with low doses of insulin, there's actually an anti-inflammatory effect. However, unfortunately, too much can lead to the opposite effect. So basically, the more insulin, the better is not really the key there. So here's a picture of images of brains that have lower cerebral glucose metabolic rate that are associated with greater insulin resistance. And here's a representation of a pathological timeline of Alzheimer's disease. If you note here, they actually don't know when the insulin levels start to change in the progression of Alzheimer's disease. They just know that there is a correlation of insulin levels in Alzheimer's disease. Interventions, we're going to spend time on those. I really want to focus on lifestyle. So it's been found that diet and physical activity actually have a positive effect on in decreasing the risk for Alzheimer's disease and essentially cognitive decline. High-fat diet was found to increase insulin resistance, amyloid accumulation, and memory impairment, even with the administration of intranasal insulin intervention. And this was done on mouse models. Also, the Mediterranean diet-like or low-fat, low-glycemic diets are associated with reduction of risk for Alzheimer's disease. It seemed that there were markers for Alzheimer's disease that seemed to decrease with this change of diet and the studies that they've done so far on. And also physical activity, they found that adults that engage in exercise 5 times a week, 30 minutes of moderate activity, they tend to have a lower brain beta amyloid disposition.